Apa nih? Ladies and gentlemen, may I please have your attention as we are about to begin. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon and best wishes to us all. Our Honorable Chairman of the Organization for Agriculture and Food BRIN, Mrs. Puja Lestari, PhD. Our Honorable Speaker, Professor Noriyuki Miura from Osaka University, Japan. Dr. Sastia Pramaputri, Associate Professor, Osaka University, Japan. Dr. Dwinita Wikan Utami, Head of Research Center for Horticultural and Estate Crop BRIN. Mr. Satrio Kridowahono, PhD, Head of Research Center for Food Technology and Processing BRIN. And our moderator for today, Mr. Andi Febrisiantosa, PhD, Research Officer Center for Food Technology and Processing BRIN, and all participants. First of all, let's be grateful to Allah Subhanahu wa Ta'ala who has given us good health and time so we can attend and participate in the sharing session presented by Research Organization for Agriculture and Food BRIN with the topic Reduction in Food Loss, Sustainable Postharvest and Food Technologies. Next, we would like to invite the Chairman of Research Organization for Agriculture and Food BRIN to give welcome remark and open the sharing session. For Mrs. Puja Lestari, PhD, time is yours.
Thank you, Ms. Wardah. Assalamualaikum warahmatullahi wabarakatuh. Could you hear me? Because now we are in the other place, and I hope the internet connection is good enough to connect us.
Clear, clear.
Okay, thank you. Good afternoon, everyone. It is a glorious moment to extend my warm wishes on behalf of Research Organization for Agriculture and Food, BRIN. And I would like to convey my gratitude to distinguished speakers from Osaka University, Japan, Professor Noriyuki Miura, and Dr. Sastia Pramaputri, and then speakers from BRIN, the Director of Research Center for Horticulture and Estate Crops, Dr. Dwinita Wikan Utami, the Director of Research Center for Food Technology and Processing, Dr. Satrio Kridowahono. My gratitude is also addressed to scientists from BRIN, universities, and other research organizations from Indonesia, Japan, and from other countries who have made it to this second sharing session with theme of reduction in food loss. Ladies and gentlemen, reduction of food loss, research and strategies need to leap forward in agricultural production and economy. Ensuring availability of food to the Indonesian population will be a major challenge in future with decreasing agricultural land and ever-increasing population. One way of achieving this target is efficient use of food materials produced and saving them as much as possible. Many approaches can be used to reduce food loss, which is found on the unintended result of an agricultural process or technical limitation in storage, infrastructure, packaging, or marketing. A subset of approaches that experts suggest are particularly practical and cost-effective that could be implemented relatively quickly and that could achieve quick gains. Smart agricultural technologies are revolutionizing in food production, which promises to increase both yield and environmental sustainability through the reduction of chemical inputs. The adoption of agricultural and food technologies expectedly can play a role in preventing or reducing food loss and waste. Technologies used in food loss reduction include smart packaging that could protect from chemically, physically, and biologically changes. Here, a systematic literature review was conducted to investigate the role of agriculture and food technologies in enabling food loss and waste reduction or lack thereof from a global perspective. Where adoption were evident, the rationale to do so was centered on boosting economic gains, reducing food production costs, and or alleviating food insecurity. Food loss reduction was rarely the principal technology adoption driver. The dynamic between agriculture and food technologies and food loss reduction deserve rigorous examination to support practical policy options that invigorates its sustainable food systems, including sustainable post-harvest. Post-harvest loss of estate crops exacerbates humankind's agricultural problems and will continue to do for their sustainability. Estate crops in Indonesia
This is Pujasari. Oh.
we apologize for this low signal in this place in Serpong, actually. Can I just fix this welcome remark? Could you hear me? Hello?
Yes. Yeah, Mrs. Puji, please.
Itu masih mau matikan, masih mematikan. Gede ini masih kecil. Halo?
Mrs. Puji, yes, Mrs. Puji.
Sorry, my deep apology. No, I just would like to finish this remark. So, and then to open this this sharing session, the second sharing session. That now we have 4 speakers, and it would be fruitful for this discussion. And hopefully you have a productive discussion and get useful information is on this second sharing session. So formally, I open this sharing session and wish you luck and thank you very much.
Thank you for Mrs. Pujarasari, PhD. Next, we would like to invite all participants to join photo session. Could all participants please activate their videos? May I ask Ms. Yusi to please help with documentation?
Okay, thank you. For all participants, please open your camera. We will take a photo session for a while. Okay, get ready. We will start from the first slide. 1, 2, 3. The second slide. 1, 2, 3. And the last slide. 1, 2, 3. Okay, thank you.
Thank you, Ms. Yusi. Ladies and gentlemen, without further ado, this meeting will start soon and will be guided by our moderator for Mr. Andi Febrisiantosa, PhD. Time is yours.
Yeah. Thank you so much, Ms. Warda. The honorable all speakers and the honorable all participants of the event. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. It's already the middle of noon, so konnichiwa to Japanese, our Japanese friend. I'm Andi Febrisiantosa, and I will be a moderator of today's webinar. So I'm very pleased to see you all here and welcome all of you to this sharing session webinar. Today's sharing session is about reduction in food loss, sustainable post-harvest and food technologies. Before I start my our session, please apologize me to using mask because we have several person here in one room. So, but perhaps I hope you all guys still feel comfort to hear my voice. Okay, ladies and gentlemen, before we get started, I would like to inform you several points so you know how to participate in today's event. We will have 4 presentations, and the presentation both from Indonesian friends as well as Japanese friends. Before the presentation begin, I will later introduce each of presenters before their presentations. And please be sure that your microphone is in mute setting. And you will have opportunity to ask a question directly after during the Q&A session in the end, at the end of presentation finish. So all the presenter will deliver their presentation first, and then we will come to the Q&A session. However, during the presentation, please feel free to send your questions through the chatting room or the chatting panel in your monitor. Okay, please feel free to join this seminar, this webinar. And now let's please welcome our first presenter. I would like to invite Professor Noriyuki Miura from Osaka University, Japan.
Oh, can I start?
Yeah. How are you?
Good.
Nice to meet you. Yeah, nice to see you today. Yeah, I'm Andi Febrisiantosa.
Can you see my slide?
Yeah, but before you start, I will introduce you first to the floor, to the audience. Ladies and gentlemen, Professor Noriyuki Miura, from Osaka University, Japan, will present the presentation entitled Work Package Development of a Smart Catalog System. He is the professor in Osaka University, Japan, and his area of expertise is International System Engineering, Intelligent Integrated System. And then he finished his PhD in Keio University, Japan, and he finished all of bachelor, master, and PhD in Japan. And right now, his career experience, he has research fellow of GSPS 2005 and 2007, and he was assistant professor of Keio University, Japan, until 2020, and right now he is a full professor in Osaka University. And his recent work related to the research and publication is related to the high precision autonomous sensor with intelligent security interface, agent physical attack, and treated computer system pervasive fit in environment. Yeah, I think this is very high reputable works. So let us, all of us, may get something fruitful from Professor Noriyuki Miura presentation. Miura Sensei, so please, floor is yours now, and we will give you around 15 minutes, and I will raise my hand if the time is about the end. Please, Professor.
Okay, thank you for a kind introduction. Fabrice Tosa.
Just call me Andy. It's okay.
So now I think you can see my slide in first.
Yes, exactly. It's
okay,
nice.
so
yes.
I would like to talk about the smart data logger system, the work in progress today. We are working this project in the Fukusaku Sensei's research project. And actually, the Professor Hirose is the leader of this project, of this research team. And I'm one of the co-investigators. Today, I would like to talk about the work in progress of this smart data logger system research project. So let me start with the brief introduction. So I believe that we now need the secure food supply chain for the food loss reduction. Now, what is the secure food supply chain? So essentially speaking, we need to strictly manage the food quality during the supply chain. So there should be many type of qualities about the food, but I think we have basically two main qualities we have to maintain during the supply chain. The first one is, of course, the freshness of the food, because we want to eat the tasty food as much as we can. So we need to, in order to do this, we need to make sure that the food freshness during the delivery should be strictly maintained. And especially we are consuming about the marine transport, because this is too long. So in order to prevent the freshness damage during the marine transport delivery time, then we can make sure that the timely delivery of the food in front of you. And also we think that the secondary quality of the food should be the authenticity of the food. We want to eat the food which is which is delivered through the trusted supply chain. So we want to make sure that this food is made by whom, and that this is the real product they made. So in order to do this, we need to prevent the food fraud by using some technology. That by using this technology, we can save the delivery opportunity loss. And finally, we believe this could improve the food loss in terms of the ethics level. So we want to make sure that this kind of unfair game should be exterminated by securing the authenticity of the food during the delivery system. Here you can see the overview of our research topic. So we have in order to strictly manage the two qualities, we mainly focusing on the two technologies, fundamental technologies to develop. And these two technologies will be integrated into the smart data logger system. The first one is the continuous monitoring of the temperature and the food gas to monitor the quality degradation of the food during the delivery, especially marine transport delivery system. And second one, the physical security framework to protect the food authenticity during the delivery system. So we want to make sure that the food is not fraud during the delivery. So in order to do this, we would like to integrate the sensors and compact the physically unknowable tag attached with the food itself to protect the food quality, both food quality and the food authenticity. The main researchers, we have two members. The first is the Professor Tetsuya Hirose, and I am Noriyuki Miura, the co-investigator with Professor Hirose. And we are both from Osaka University. And Professor Hirose is in the electrical engineering department, and I'm in the information science department. But both of two are actually the same, working in the same field. We are both working in the IC circuit design engineering field. And Hirose sensei is the expert of the ultra low power circuit and sensor, the battery circuits and systems. So he has the strong knowledge on how to integrate the very accurate and low power sensors in our data logger system. My expertise in the proximity wireless communication links and physical security technologies. So we can both do together working in the previous two research topics to integrate the pioneering sensing circuits and security circuit into the smart data logger system. Okay, so each activity is summarized in this slide. So the Hirose sensei is working on the fundamental technologies for data logger sensing system. Mainly, he will work for the low power temperature sensors development, and he can make another building component, which is food quality degradation monitor circuit. This would directly monitor the food degradation in the integrated circuits. And I will work on the more on the security side. I will develop some kind of sensor PUF technology for protecting the food authenticity. This PUF is kind of the word maybe you don't know. I will explain that this word meaning of this. I mean the concept of the PUF later. This is the meaning is just a physically uncloned function, but I will explain the detail later. Okay, so I will first start with the introduction, the brief introduction of the Hirose sensei's work. What he would like to develop finally is the direct food quality degradation monitor. And what he will do is to make the integrated circuits which has the sensor front end and also the modeling model the food quality degradation characteristics directly into the circuit. So here, for example, we can measure the temperature or some kind of gas components, but we don't know how to. We can understand the degradation level maybe after the gathering all the data together and analyze the process of all the information together to calculate the food degradation level. But what it actually needs to deliver many data, and we need to finally do the heavy processing after the data gathering. So this is not real time, and this is not the on-site system. So what he would like to do is to make the integrated circuit, which can have the similar operation characteristics to model the degradation of the mechanism. So by doing this, we can directly digitize the food degradation level as like this kind of equation C. So by doing this, we can make the circuit and compact, and we can know the food quality degradation on site during the delivery system. That's why we can make the feedback control to maintain the food degradation level. Okay, so this can be seen as this graph. So here you can see, for example, if the quality degradation, food quality degradation can be monitored by using this kind of circuits, we can understand how the food quality is degraded during this shipment time. And we know that some kind of limit of the degradation, if the degradation level exceeds this, we cannot deliver this food, then it's going to be lost. So if the ideal delivery case, we can make sure that the delivery degradation level can be far below the limitation. But what if during the delivery there's the air conditioning failure? What if happens? Then the containers, the temperature will be raised very rapidly. So this happens on site, and the degradation monitor can directly monitor the food quality degradation at real time. If we can find this, then this food cannot be delivered in time. So we can make a feedback control to the air conditioning to prevent the degradation. Based on this, the direct degradation monitoring circuits. So this is the idea what we can do. But the point is that we need to make this kind of circuit to be as small as possible, because the container, the area is limited. That's why we want to make this kind of calculation system into the integrated circuits. So that's the idea. The Professor Hirose is working on this degradation monitor development. And the second half is the food authenticity management. Is this kind of thing is related to the information security field. But I am working on the physical security. This is not the very much similar with the conventional information security. The information security is mainly based on the protecting the information from the attackers. And the most powerful tool, you can understand that this cryptographic processing is one of the actually one and only tool to protect the information from the attackers. But what if there is the physical attack on the cryptographic system? If of course the cryptographic processing is mathematically proven safe, but that kind of process is anyway done in the processor's hardware itself. And if there is physical attack on the processor hardware, the attacker can actually steal the information. So this kind of physical attack is the problem on the information security now. So we need to have the information security in the physical level. Otherwise, we cannot protect the information from the valuable information from the attackers. This is the idea of the physical security. And actually, the food information security is very much related to this physical security, because if you think about the protecting the food and its authenticity, means we need to protect the food physical entity itself and its associated information. We need to protect both. So in this case, we need to have the physical security to protect both food and its information. So here you can see if there is the variable mangoes, and this mango was made based on the brand XX and made in YY. But this is the information is related to these individual mangoes, and we need to protect both this physical mango and its associated information, both. In order to do this, people may use some electric tag attached onto this physical mango, but this is actually not perfectly secure, because the people may able to counterfeit, make the fake tag and attach to the different fake mangoes. This is kind of easy way to make the food fraud. Right. So what we have to do here is to make more complex, unseparable relationship between mango itself and its associated information. So what we can do is to the sensing data based on this individual mango data can be written in this electric tag, and this information cannot be separately measured because we have the smart data logger system. This is all go with the mango and the continuous monitoring the food quality of this individual mango, and this data is only measured at on-site. So we can make sure that the informations during the delivery system and the delivered mangoes relationship, it cannot be separatable, right? So by using this relationship, we believe that this mangoes, the authenticity during the delivery system can be secured. But the point is, one more point is that this kind of data itself can be make the copy, or that attacker can make the fake sensor data. This is the problem. So that's why we want to make sure that this data can be measured by these individual sensors together with the mango. By to make sure this, we can use some kind of technique, which is physically unclonable function. The physically unclonable function is the path is the idea is that this is the artificially unclonable input and output relationship. This is the definition of the function, and I think that you can understand the actual example here. We can make this kind of physically unclonable function in the silicon IC chip by using the semiconductor fabrication process variations. For example, if there is the ICs made with the based on the same circuit schematic, I mean, same circuit, but we have the semiconductor fabrication process variation, which cannot be controllable by us. But so by using this variation, even if the same input is given, the output will be different. So this is the kind of, we can see like the fingerprint of the IC device itself. So same input, but different output. And this output, the pair of the output input cannot be clonable. So we cannot make the clone of this input output pair because this relationship is made by the uncontrollable variation, process variation during the process step. This is given by the uncontrollable semiconductor process variation, something like this. So by using this kind of functionality, and we can combine this functionality with the sensors, then we can make sure that this sensing data could be measured by this sensor, individual sensor delivered with the food, target food itself.
Add me 2 minutes there.
What?
2 minutes left.
Oh, thank you.
Yeah.
I can finish
Yeah,
in 2
yeah.
minutes. So the combination of the sensors and the path, I have the recent work. In this case, we have demonstrated the sensors path realization with the cameras. So this is a very easy way to understand this concept. So what we have done is to prepare, in this case, the 5 same model cameras, and took many photos, and using the machine learning technique to identify the photo, and it's taken. We can identify that this photo will be taken by which cameras. So we can identify the device, the camera device, which take this photo. So if we use something like 10, 20 photos, we can identify the 100 photos, almost 100% accuracy by using some pre-processing technique to amplify the individual sensor device characteristics. So we can distinguish the very small difference of the device sensing characteristics from the taken photos. And this kind of technique can be used for detecting the fake data and counterfeiting in the data itself. Now we're working on the Japanese lapis technology industry to integrate this kind of temperature and quality monitor and the sensor power circuits into the microcontrolling unit to develop the data logger system, something like this. By integrating this kind of additional function into the microcontrollers, we can reduce the cost and also shrink the size.
Why are you so quiet?
Okay, so today I will introduce the working progress of developing the smart data logger system. The idea is to keep the food quality and traceability. In order to do this, we use the temperature, the quality monitoring circuit, and also the sensor power circuits for the comprehensive protection of the food quality and supply chain. So also we are working together with the industry partners to realize the low-cost solution for practical use. Thank you for attention.
Yep, thank you so much, Miura Sensei, of your very excited presentation. Please stay with us because we will have question and answer sessions at the end of our session. And I think through your presentation, there will be many questions for you from the audience. Okay, thank you, ladies and gentlemen. We will then continue to the second speakers today. Let me introduce or invite first Dr. Sastia Pramaputri. I'm very familiar with this name. Hello, Dr. Sastia.
Hello.
Yeah, are you there? Good afternoon. How is going on there in Japan?
Yeah, very good. Thank you.
Okay. Thank you, Dr. Sastia. You are become my close friend now because we have two times one friend. Okay. Ladies and gentlemen, Dr. Sastia Pramaputri actually has presented in the first session our sharing session, and now she also would like to present her presentation entitled Triple Helix Collaborations Efforts to Improve the Quality of Indonesian Coffee and Cocoa. Is that correct, Dr. Sastia?
Yes.
Oh yeah. Please let me introduce about her first to the audience. Dr. Sastia Pramaputri finished her bachelor in Bandung and continue master and PhD in Osaka University since 2008 and until 2010. And right now she is a research training she is worked as a associate professor in Osaka University since 2014 until now. And she works in the area of metabolomic approach and then application of gas chromatography mass spectrophotometry, based metabolomic in food science and technology. So her research area actually generally metabolomic and natural product. And she already published in the very high reputable journal. So there's no question about her expertise in this our session today. He is very good to give the presentation. Ya, Dr. Sastia, silakan untuk mempresentasikan. Please, I give the floor for you. Hopefully we'll finish in 50 minutes. Oh yeah, 20 minutes okay for you today. Okay, yeah, please.
Thank you very much, Pak Andi. It's really nice to meet you again today. And Ibu Puji, selamat siang, Ibu Puji. Very good afternoon to everyone. I think a lot of us are joining from Japan, from Osaka, and also from many different cities in Indonesia. Our PI, Professor Fukusaki, and I saw Muranaka Sensei, Professor Muranaka, Associate Professor Shima are also here. Several members from the JST's COI Next are also here today, and hope through this sharing session we could have a fruitful discussion to discuss about potential collaboration in the field of food technology, specifically because I saw that two other speakers that will be giving a talk from BRIN today will have a talk about coffee and cacao. And happens to be my research also has a lot with coffee and cacao. So I would like to give a talk today about our work in coffee and cacao. So in our project, Professor Fukusaki has already explained in the first sharing session that we aim to reduce food loss and waste. So food loss, waste reduction, innovation hub is our project. And Miura Sensei has already explained about the development of smart data logger system. And hopefully in the third sharing session, Muranaka Sensei, his expertise in plant biotechnology, will be speaking about the use of recycling-oriented food materials. And our expertise, my expertise is on metabolomics, specifically on food metabolomics. And about coffee, I think a lot of Indonesian people like coffee, and of course, Japanese people also really like coffee. We know that coffee has many different kinds of taste and flavor. We know, for example, coffee has bitter or astringency, sweet, acidity, and fruity. But our lab works with identifying the component, what makes this food bitter and astringency, for example. So it's bitter because it has high caffeine content, astringency comes from chlorogenic acid, sweetness comes from different kinds of sugar, acidity also comes from different kinds of organic acids. So the relationship between coffee taste and its component is basically what we aim to do in our research field. So in our laboratory, we have already done a lot of work about these different aspects of coffee and cacao. The first one is about authentication. So Professor Miura has already mentioned the importance of food authentication, adulteration to prevent food fraud, food traceability. And therefore, this is one of the major research topics to characterize what is unique in the coffee coming from different origin, for example. Then we also deal with, other than authentication, to continuously optimize or understand the effect of post-harvest process or growing temperature or altitude in order for us to do quality improvement of Indonesian coffee and cacao. This is just one of the examples of the early research that we did on coffee. This was in fact our first publication on Indonesian coffee metabolomics. We did research on kopi luwak authentication. It was published in 2013 at the Journal of Agriculture, Food and Chemistry. And we identified that the original kopi luwak has these three distinct markers. It's always higher in these markers concentration, malic acid, citric acid, and the ratio of inositol and pyroglutamic acid were able to act as authentication marker. So hopefully working together, our field, for example, like metabolomics, once we identify the component like the metabolite marker, we can work together with scientists like Miura Sensei, who are very good at making sensors or making portable devices in order for us to make this a routine procedure in the industry that is low cost and efficient. So other than that, we also work to profile the different characteristics of all Indonesian specialty coffee. We employed metabolomics to analyze green beans from Arabica coffee, coming from 10 different origins in 6 different islands in Indonesia. So very comprehensive analysis. And we found, for example, that each of the production area gives different coffee taste and chemical characteristics. Actually, we Indonesians know that the coffee coming from Mandailing will be different taste with Toraja or Papua or Bali. But in our research, we could inform have a more quantitative information, for example, western part of Indonesia has higher galactinol concentration. Middle part of Indonesia has Arabica coffee beans with high concentration of these metabolites. And also eastern part of Indonesia has other markers. So this also has been published in 2019. And if you are interested, we have already profiled all Indonesian specialty coffee Arabica that are famous in the market and find the authentication marker or discriminant marker that is unique for each origin. Next, we know that different coffee coming from different origin will have different quality and different taste characteristics, but we would like to know what are the factors that are important for coffee quality. For example, if we see high specialty coffee, high quality specialty coffee in Indonesia, it always has the information of geographical origin. It has the information of altitude and what kind of post-harvest process. For example, Mandailing cultivated in blah, 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 MASL, or for example, 1,200 meter above sea level. And the post-harvest process, for example, it's using honey process or dry process. It's usually in the label. But how are these factors important to determine coffee quality? And which one is more important? So I was curious to ask this question because I see from a lot of coffee science book, they say altitude, for example, plays a role in coffee quality. The higher altitude, the better the quality. Is it true or not? So we also published in 2020 and found that actually among all of these characteristics based on our analysis, post-harvest process is a dominant factor on coffee metabolome profile. So regardless where they are from and which altitude, if they are subjected to different kind of post-harvest processing, you could see significant difference, particularly in the post-harvest process that is dry and the post-harvest process that is hybrid or wash process because the involvement of water and natural fermentation. So here we compared coffee coming from different origin, different altitude, employed in different post-harvest process. Based on this kind of analysis, we could see very clearly that the clustering was based on post-harvest processing, and therefore the dry process will have a very unique characteristic, and it's correlated with amino acids, sugar, organic acid compounds, and the wash process and the honey process will have higher galactinol and glutamic acid content. So these kind of graphs are the result that we could get by understanding different coffee coming from different origin, coffee from different altitude, and coffee from different post-harvest process will have different intensity of metabolite. So then we could identify, for example, if we are interested to produce coffee with this particular high content of some metabolite, then we could modulate the post-harvest processing, or we can choose to get from what altitude or from what origin. So this is the research on coffee. Today, I only have 15 minutes, or Pak Andi says if a little bit, 20 minutes is okay. So I cannot talk a lot about what we did, all of them, but I would like to talk more about our latest research on cacao. So for coffee, we have already started, as I mentioned, from 9 years ago, 2013, and many publications we have already accumulated, and the research on coffee is quite solid. But I was quite concerned because, nowadays we have increasing appetite or demand about bean-to-bar single origin chocolates. So before, when we eat chocolates, in my childhood, for example, we have many different brands like Silver Queen, it's my favorite. It doesn't matter, or Nestle, Kit Kat. It really doesn't matter where the cacao beans are from, because it's going to be mixed with a lot of flavoring, a lot of sugar, a lot of milk. Then it will taste like that chocolate. So it's not really it's so important about the quality of the green beans itself. But bean-to-bar chocolate, like the single origin chocolate, is very expensive because the cacao fruit usually comes from one origin. And for example, in this case, like Krakatoa brand from Indonesia, even they have the same recipe, but if they use different cacao beans coming from Sumatra or like one is from Sulawesi, they would have different taste profile. And this is because of the flavor that is generated through the fermentation process of the cacao beans, which makes them have different taste profile and will result in different taste of chocolates. So I was quite sad to hear that Indonesia has dropped from the third highest producing country for cacao to become sixth. And a lot of the cacao plantation now is being repurposed to build other plants. And I think we should still continue to produce cacao because it's a very important commodity, export commodity from Indonesia. And we have so much potential, but for example, the center of cacao production in Sulawesi usually produce cacao in the non-fermented and then sold in cheap price. So even we are high producing country, we are not famous for high quality cacao beans or fine cacao beans. Why? Yeah, because it's not fermented well, for example, and we don't have any information about what is unique characteristics of cacao produced from outside of Sulawesi. Actually, if we do a very good extensive analysis on the diversity of cacao beans coming from different area, then hopefully we could reduce food loss and cacao crops that are produced in different area can be sold as a fine cacao bean having distinct characteristics that is unique only to that area. Then that area can have a better utilization of the cacao produced. So for this, we work with Indonesian Coffee and Cacao Research Institute and an industry in Jakarta called Pipiltin Cacao. And we received cacao fermented beans from their foster farms, 17 origin places during the 2018 harvesting period. And we saw that the classification was not like what we saw in coffee. In coffee, for example, those that are produced from Sumatra will be clustered closely to Sumatra. Like we see a very clear clustering based on the origin. But for cacao beans, I could not identify at first what is the clustering, what is the effect, what is the factor that determines this clustering. Because, for example, East Java here are separated. Both are from East Java, but they are different. So I was wondering what would be the factor that determines the classification of cacao beans. Then we could see a distinct metabolite profile exist based on the origin place. And it's quite interesting also to see what kind of characteristic metabolite is produced from cacao, from what origin. And what I'm very happy about is we could see in Japan, there's a lot of chocolate that is produced like GABA chocolate, because it says that GABA chocolate is very good for anti-stress and relaxing effect. But our cacao beans actually have high intensity of GABA. And we could see from this kind of profiling, which area have higher intensity of GABA compared to other area. Then if we could find very unique added value of that area, for example, they have additional concentration of beneficial compounds, then we could have this as a marketing strategy to market the cacao beans coming from that area better. Then we would like to investigate further what is the correlation between environmental factors and of origin place and metabolite profile. And we got the information, for example, about latitude, longitude, altitude, temperature, rainfall, and everything. Then in short, from our study, we found that these three factors, minimum temperature and altitude, highly correlates with the classification that we observed. So perhaps it's not about origin, but it's about the altitude. So the higher the altitude, then it will affect the temperature. Then temperature becomes colder. Then if it's colder, then it will have similar characteristics. Even if it's in East Java, even if it's in Sumatra, but if they have similar terroir effect caused by altitude, it seems that that is the factor for classification. So now we are doing a analysis together with Puslit Koka in Jember to identify whether this hypothesis is true by doing the fermentation in two different locations. One is in high altitude with lower temperature, and one is low altitude in warmer temperature, to see if this is really the factor that is responsible for the discrimination that we observed in metabolome analysis. We also found what kind of metabolites are affected as the altitude is grown in higher altitude or temperature. For example, here, GABA can be seen to be positively correlated. So the higher altitude cacao beans will result in higher concentration of GABA. So this is also interesting, so that we could further develop quality of Indonesian cacao beans, especially those with added value. So next, I would like to illustrate the collaboration between academics, industry, and government, as I mentioned, triple helix effort to improve the quality of our products. So it is okay to do research about cacao beans, but unlike coffee can just be roasted and grind and drink, right? But with cacao, it needs to be made into chocolate. So after cacao beans, there's additional processing that will determine the final taste. So in the bean to bar process of single origin, from raw bean, there's a fermentation, there's roasting, there's refining, there's conching. So there are other processes to make this into final product. So the product production process also will affect the quality of chocolate. So we would like to investigate, starting from the bean to bar, what are the metabolite changes that happens and how we could modulate the quality of the green bean to make a still high quality cacao or high quality chocolate. So for this, we expanded our metabolite analysis. Before, we only focus on hydrophilic low molecular weight compounds, but now we also include the analysis of volatile compounds so that we could check the influence of aroma, because it's also quite important for the taste flavor of chocolate. So we work together with the industry. Our task is on the GCMS analysis, and for non-volatile and volatile compounds, we combine that data with sensory evaluation and multivariate analysis. And we use 5 types of sample coming from 3 different origins. And this is the workflow of GCMS method. And here we could see what kind of metabolite changes after raw bean, after fermentation, then after processing. So the most significant change happens during fermentation. That's why this indicates the importance of fermentation to make high quality cacao beans. If it's not fermented, then no flavor component can be generated and the cacao beans will taste bland. Then the unique characteristic of each origin will not appear without fermentation. So as seen here. So here we also could tell the difference between the chocolate that are produced in different recipe. For example, like East Java uses cane sugar, whereas the Flores use coconut sugar, gula kelapa. So from here also in metabolome analysis, when we analyze volatile components and non-volatile components, we could see the difference between the low cocoa content and high cocoa content. The samples are separated, of course, but we also can find the difference between the samples that uses coconut sugar and cane sugar. So this also have distinct metabolite profile due to the influence of what kind of sugar is used for making the chocolate. So here we could identify more in detail about the chocolate component, what is responsible for the taste profile. And later on, we correlate this with the result of sensory analysis. What kind of chocolate is more liked by, for example, Japanese panelists, and why they are more liked by Japanese panelists is the research that we did with chocolate. So we found the correlation between sweet, dairy flavor, bitter, astringency, and what kind of metabolites are responsible for each of the flavor component. 2 minutes? Okay. Yeah, so this is actually already the summary slide. So we thought that we could find from the bean to bar process this production process of chocolate also can further alter the component that is in the final chocolate product based on the recipe used. Then we can modulate the characteristic of the final product. So what is next? We also work together with the company. This is actually the company that we established, my family established in Indonesia, to help support the farmers and to use the research that we did with Indonesian agricultural products and improve the export of our good commodities to Japan. And also working together with the representative, for example, like Indonesian Embassy in Tokyo and Consulate General in Osaka, we work together with the Japanese industry to export coffee and cacao to Japan, especially from many different areas, to introduce more diversity of our Indonesian cacao and coffee beans. So I would like to close this talk by giving an advertisement. So this is very important, the most important slide. I would like to invite everyone who is here today to register to our international symposium that we will do in Osaka University. It will be done in a hybrid fashion. We will have the speakers from Indonesia coming to Japan as well as online, and the registration is free. So I hope that I will see a lot of you here, and after this talk I will send the link to register to this symposium by chat, and I hope through this symposium we could exchange knowledge and situation with each other to work together and reduce the problem of food loss and waste. With that, I would like to thank you for your kind attention and very happy to answer questions. Thank you very much, Pandi.
Yeah, thank you so much, Putri Sensei. Is that correct? Yeah, that was Sastia Putri. Of your presentation, I think today we have a very fortune to see the our Japanese friends presentation. First presentation from Miura Sensei and second one from Dr. Sastia. So after this presentation, we just directly continue to the third presentation, and for the third and fourth presentations will be from the Indonesian friends. First presenter from Indonesia is Dr. Dwinita Wikan Utami. She is the head of research center for horticultural and estate crop BRIN, and will deliver the presentation entitled "On-Farm Technologies for Food Loss Reduction in Coffee and Cacao." Let me invite Dr. Dwinita. Dr. Dwinita, hello. I hope Dr. Dwinita has already here with us. Dr. Dwinita? Hello, Dr. Dwinita. Dr. Dwinita? Okay, perhaps we have to wait Dr. Dwinita while we are waiting. Yeah, I encourage you to register to this symposium that already promoted by Dr. Sastia. And then, oh, maybe I will switch.
I think you can change to me.
Yeah. I will switch the session presenter to Dr. Satrio because he already stay with his presentation and will ready to give us the his presentation. Hello, Dr. Satrio.
Yep, Mr. Andi, Dr. Andi, I'm ready.
Yeah, Dr. Satrio Kridowahono. We will go to Dr. Satrio Kridowahono. Good afternoon.
Good afternoon.
Yeah, Dr. Satrio Kridowahono will present the material related to the food technology experience, freeze drying, food preservation, and cocoa processing cycle. And he is the head of Research Center for Food Technology and Processing, BRIN. And right now, let me introduce first about Dr. Satrio profile. Yeah, Dr. Satrio finished his PhD degree with the fast track. Wow, very excellent. In School of Engineering, Future Industry Institute, University of South Australia. And within 4 hours in 2015 until 2019. And then his area of expertise is post-harvest technology. His recent publication and work related to the natural zeolite and plasma surface engineering for innovating by gas purification and advanced absorbent, and several work related to the post-harvest of food. And then his career, right now he is the head of Research Center for Food Technology and Processing, National Research and Innovation Agency, BRIN, from 2022. I think that is his profile. And please, Dr. Satrio, the floor is yours, and hopefully can be finished within 10 minutes before discussion. Yeah.
You discount my time so much, Mr. Andi. That's okay. Okay, thank you.
I will raise my hand if the time is about to be
yeah.
No problem.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Selamat siang, good afternoon everyone, especially for our Japanese friend, konnichiwa. In this time, I will present, actually not present, maybe just for sharing some food technology experience in our research center. So maybe I will not present in detail, not just because Mr. Andi discount my time very much, but yeah, if you know in detail, you will not come to our research center to collaborate. So if you want to know the detail, please come and we can collaborate in all area of research, particularly in food processing and food technology. This is my research center, our research center, Research Center for Food Technology and Processing, BRIN, in Yogyakarta. You can see the building. It's the new one, and it's located about 32 kilometers from Yogyakarta. Yogyakarta is one of the big city in Central Java, one of island in Indonesia, the most dense island in Indonesia, most populated island. As mentioned by Bu Puji in the previous sharing session, this is our scope of research in our research center. So you can see that all of food technology and food processing is our area or our expertise in here. So since BRIN is a new institute in Indonesia, new research institute in Indonesia, now we still in transitional, so I still try to connect it all of the technology, food technology in Indonesia, especially from various research center before, which is collaborate into one research center. You can see in here the scope about the material, food ingredient or food material, basic process, advanced process, preservation, and food program. Our research center, my research center, has a strategic program or targeted until 2024, particularly to support these three kinds of program. First one, stunting handling, one of the most problem in Indonesia, one of the priority national research in Indonesia, how to handling stunting. So it's related with the food security revitalization. Second one about food processing, processed food packaging. In here we develop some technology, not only the existing technology, but we also try other technology, especially to improve the shelf life of food more than 6 months. That's our target. And then the third one, this is the newest program for my research institute. It's related with halal research and innovation, particularly how to detect the halal and how to substitute some halal material based on the local material, local food resources. This is a research group in my research center. There are 8 research groups. I think I will not read it in detail. I will share the presentation, or maybe a committee will share the presentation. All of the research group work about work in food processing and food technology, as the scope in the previous slide. For the future, because BRIN is the one and only research and development institute in Indonesia, we not only work only in the 3 main program, but we also have a dream, have a future topic for food technology. We can see in here, we need some technology for nutrient and energy dense food, high nutrient food, maritime food product exploration, particularly because Indonesia has vast maritime, vast ocean. So there are many resources which can explore, and then about nutraceutical or functional food, and then food additive, food biotechnology, food preservation, advanced food product processing technology, food packaging innovation, and about the detection, how to create a fast and easy food detection. Based on the first sharing session, I tried to make a summary that this topic can collaborate with Osaka University, but it's not, it's my opinion. It's just my opinion. So I think after this sharing session, I think we can see there is another field that we can collaborate about future food research topic. Why I chose three kind of research food technology experience, which I want to be shared, because the first session, in some presentation, I hear about freeze drying. So the first one, it's about freeze drying. We have a facility to conduct freeze drying research. This is the main equipment, and based on our experience, we already use it for various purpose. First one, you can see in here, this is Dr. Andi as the researcher. We process cheese combined with spirulina, one of algae or maritime resources. It's combined and process it using freeze dryer. Why we use it? Because to keep the cheese character, so it can have a specific characterization or specific taste or something like that. This research still ongoing, so we don't have many results. But I think if we want to collaborate how to improve this product, or have others' idea, maybe there is another needed in Japan. Maybe we can little bit change the resources and create more about the cheese processing. The second one, in freeze dryer, we have experience in how to proceed aloe vera gel. In the first step of our research, I think 2 years ago, we convert the aloe vera into gel and use it as part of a beverage. In last year, we have experience to convert it in use or process it using freeze dry and produce material, a very light material like cotton candy, white, light, and yeah, you can see in the picture like a cotton candy. The third one, we also process it phycocyanin. Phycocyanin is one of dyes compound from algae, from spirulina, which created a blue ocean dye, and it's already applied in various food, and one of them have a registered patent in Indonesia using for jelly candy. The previous technology we use foam mat drying technique, and now we try to proceed with freeze dry. That's about how to proceed food using freeze dry. And another one, we also try to proceed anthocyanin extract. It's a part of smart packaging or smart indicator, or maybe for food also. So we have many experience in freeze dry. Also, this one, we have experience also in freeze dry to proceed master sheet and incorporate with the film, and we can create antimicrobial packaging from that process. The third part, the second part is about food preservation. As I mentioned before, that one of our target, our program is to increase shelf life of food more than 6 months. The main technology that we already applied in Indonesia, it's already mentioned by Bu Puji in the previous session sharing about traditional canned food technology. We already applied in most of the island, most of the part of Indonesia, most of many traditional food already packaged and can increase shelf life more than 2 years. It's not new technology, but it's new applied because Indonesia has many various food, traditional food, and also various food resources. Not only can we also improve the thermal sterile process used for other packaging, such as for pouch, also for HBRG, high barrier retort grade. Also, we improve to increase shelf life for processed food. This one, we try to use new technology using a plasma and also nuclear or gamma irradiation to increase food shelf life. We still ongoing research for processed food, but I think and some literature say that this also has a potential in fresh food. It's still ongoing research. In the previous session, also I hear about Kitosan. We also developed Kitosan as part of active packaging to improve shelf life also. Then this one, how to preserve food using natural oil from a local plant in Indonesia. This is and the second one in the bottom of slide is convert the egg into egg powder using spray dry. It's also increased the shelf life. And we also has one patent, domestic patent about using citrus leaf as food preservative. Our experiment, it can increase one of Indonesian snack, dodol coklat, cocoa sticky rice cake, from 1 week into 28 days storage. Because two previous because Miss Dwinita not yet present, talking about cocoa. Miss Sastia Putri talking about cocoa. I also try to share some of our experience in cocoa. So what we can do with cocoa processing in here, particularly how to utilize the waste. As we know that cocoa is a food as the main product, and then the waste, what we can do, we apply it in for feed and also for other product. In detail, we can see in here, this slide is one of our village, our community development and one of tourism village in Ngelanggeran, in Yogyakarta. We already transfer technology to process the chocolate, the cacao from previous they only cultivate and then harvest and then sell it directly. Now they have one of cocoa production in 2014. This is the history. So our community development conducted at 2014 until 2016, and then after that we tried to improve the product for food, particularly for some functional food from cocoa. Two of them already get registered patent in Indonesia. First one we impregnated with the nuts, local nuts, so it increased iron and zinc contained in the product. So it's related with our program before about the stunting handling. And the second one, a probiotic chocolate that's appropriate for diabetic patient for snack. What about the waste? The waste, we already have a technology to make it a silage. The expertise in this part already in Pak Puji in another research center, but I tried to present it in here, so we can proceed the cacao pod into silage and can consume by the cattle. The second one, we also has technology to convert it into liquid smoke that can use for food preservation also. The third one, we try to extract the cocoa pod husk and impregnate it with the packaging and can create active packaging. So it has antibacterial function, so it can utilize in advanced product.
1 minute, please.
Finally, finally, this is our new facilities. So I invite all, especially for all Japanese friends, to come and collaborate in our research technology, research center technology. And you can see in here the video take about last year. So it just before we are fully operated. Now we are fully operated as a research center, particularly in food technology and processing. Last slide, it's for inspiration. We already met Indonesian president even our Indonesian Vice President come to my research center to inaugurate my research facilities last month. So please come to my research center to make very kind, very good, very excellent collaboration to improve food technology. I think that's all my presentation. Matur nuwun, arigatou gozaimasu. Thank you. PRTPP BRIN, Technology for Food, Food for Future. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, Dr. Satrio, for your informative presentation. I come to know that we have a lot of sorts to be a topic of our collaboration. Yeah, ladies and gentlemen, now is going to the last presenter, but not least, I pleased to invite Dr. Dwinita Wikan Utami. Hello, Doctor.
Hello.
Yeah, good afternoon. Sorry.
Sorry,
Yeah.
it's a delay.
Okay, it's no problem. Yeah, ladies and gentlemen. So now we will going on to come back to the topic of coffee and cocoa. But last presenters, our three last presenters already delivered the presentation related to the off-farm technology, and now the topic will be on-farm technologies for food loss reduction in coffee and cocoa, and will be delivered by Head of Research Center for Horticultural and Estate Crops, BRIN Indonesia, Dr. Dwinita Wikan Utami. Let me introduce first about her profile. Dr. Dwinita Wikan Utami now is the Head of Research Center for Horticultural and Estate Crops, National Research and Innovation Agency, BRIN, 2022 up to now, until now. And she finished her PhD in plant breeding in Bogor University in 2004. So the area of her expertise is molecular biology, and she has worked a lot of done in the work in related to polymerism plantar survey and the Indonesian improve varieties to support development of new submergent tolerant varieties, the varieties of the bacteria as well as plant. Yeah, we hope there are a lot of things we can catch up from the Dr. Dwinita presentation. So floor is yours, Dr. Dwinita. Hopefully we'll be finished in 15 minutes, more and less. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you to Pak Andi as a moderator for this session, and greeting to Professor Noriyuki Miura and also Bu Saskia. Good afternoon. It is great I could meet you in the sessions. I am Dwinita, representative of the Research Center of Horticulture and Estate Crop of BRIN. Here, I would like to share some activities about on-farm technology for food reduction, especially in coffee and cacao. Okay. Okay, this is the title. I think next, the title is on farm. Oops. So this is the last one. Okay, slideshow. Start of the slide. Okay. So related to the title about the food loss, refer the reduction in food quantity or quality due to the decision and behavior, change of decision of behavior food provider outside of retail, food services providers, and also consumer. Therefore, food loss refer to the loss of food when it passes between the producer supply chain and the market. For example, food loss has been reported in Banyuwangi, actually, where the dragon fruit farmers threw away about 10 baskets of fresh fruit into the river in about January in 2019. So this is because the farmer is not successful in selling the dragon fruit, their harvest, the collector, because it is not accordance with the quality desired by the market, even though it is still fit for consumption. Okay, next. One of the scope of the on-farm food loss is the loss of food that generated during the primary production. It can be broadly be classified into the two categories, actually, the practice-based and also market-based. A practice-based is a loss, direct loss generated during the cultivation and harvesting, while on market-based would be a loss generated by event outside of the farm, which would have an impact on production. And the example, I think I can skip, like, okay, next. Okay, so let's see about the coffee and cacao. Coffee and cacao is the two of the estate commodities, has a vital role in national economy in Indonesia. Indonesia is also has the geographical and climatically well suited for coffee and cacao plantation. What about the potency and also constraint in a coffee and cacao plantation in Indonesia? So coffee robusta is the majority popular in Indonesia, more suitable for lowland, also high temperatures, high level of humidity, and also significant rainfalls. But it has come a constraint related in production. 90% of Indonesia coffee production comes from small farmers that have less than a 1 hectare field. The problem is more need on a low yield and maturity, and mainly susceptibility to climate factors such as extremely on drought and also extremely in rain, so that affect the flowering and ripening of the coffee on cherries. So another constraint is also the lack of pruning and minimum of agriculture inputs. So what about the cacao? Cacao has the potential because the high economic value and growing market demand. Nevertheless, the quality of the cacao beans produced is the main obstacle the cacao export, because the quality of the cacao made in Indonesia is generated low, because unfermented beans lack of the flavor and also aroma. The low quality of cacao beans is also associated with the high incidence of insect and also disease, and also the lack of pruning, sanitation, and many of the agriculture inputs. Next. So we propose on the 3 strategies of reducing food loss on farm on coffee and cacao. First is a good agriculture practices. In this strategy, there were 2 approaches can do in such firstly is a breeding and enhancing cultivation technology to improve yield quality. So through the breeding, we can develop the superior variety, like has high yielding varieties, tolerant to biotic and abiotic stresses, and also have a good quality and taste or good and on aroma. The varieties have to support, these varieties have to support it by the cultivation technology, such as the technology on composting, weeding, pruning, and also the seedling, and pest and disease control also. So about the injection, fertilizer is also need to apply, and other agriculture which prefer, of course, the preferable not in chemicals. So, and secondly, we also use the approach on metabolomic study to uncover possible product metabolites. The target on this approach is utilize the genetic resources, which may be less preferred or unmatch the quality product desired by identifying the nutritional and phytochemicals compound. So the product could be used and prevent to food loss. Next. continue it. The second strategy is a good handling practices, which cover on a good quality of seedling stock. We can propose here the somatic embryogenesis technique could be applied as a tool to large scale of vegetative propagation. The aspect of the time harvesting is also crucial to obtain the quality of bean. And the last strategy is also reduction in farm food loss. It's a good distribution approach that covers the through smart farming and startup system creation. This approach needed supported by the data, digital, and also remote sensing technology, and the Internet thing represent of the for future agriculture, and also require the development of system that connect supplier and buyer so they can be transferred to other business or consumer system to prevent a food loss. Next. So this is the kind of research activities that we have. So related to breeding and field adaptation, that is for new cacao clone or new cacao, yes. Cacao superior varieties resulted from breeding activities. We already have several actually, like such as here the ICCR 11 up to 14. These varieties have the character, the high production, white seed, thin fruit skin, large seed size, and also have the more than 55% of fat content, and also the high adaptability. We also developed a new cacao clone from crossing between the two high yielding, and we did it in a location test in Kebun Percobaan Pakuan and also in Cahaya Energi. And for the selection target for this population is the resistant to cacao pot rot or BBK test in a laboratory and also in observation in the field. And we also screen also for the character yield power and also the cacao bean quality. Next. And here a lot of activities about the enhancing cultivation technology on the suboptimal field using the biofertilizer and also the amelioran. So the activities start from the soil sampling, isolation, trap culture, identification, and inoculum multiplication. We have some positive result on these activities on increasing the growth of cocoa seedling in acid soils and also tolerant to drought stress. Next. This is all the review, about the review of the current activities in a coffee. We have some coffee accession collected from several locations in Indonesia. And the genetic diversity clone analyzed already on a species determination and also for breeding population development purposes. Many accessions that have some potential characters will continue the in vitro treatment for conservation and also the micropropagation purposes. We also have the breeding stock field garden for Robusta coffee that planting some superior Robusta varieties such as the here I mentioned the BP 936, BP 534, BP 40, and BP 308. These all the varieties are good character on high production, good quality and taste, and also high adaptability to drought tolerant and also resistant to nematode. We also have an established cultivation system as an optimal composition polyclonal of Robusta varieties according to the climate and altitude variance. We classified on more or less than 400 meter GPL for altitude and add A to G variance for climate. And this is all the varieties composition. So this is as the breed lines diversity work optimized for coffee production. Next. Okay, so this is about the current status activity of the cacao. We also have some accession of cacao collected from several locations in Indonesia, and the genetic diversity analyzed to identify the genetic distance for parent crossing to develop the hybrid progenies. Several activities also done on the biochemistry and phenotyping in a part of cacao, such as a bean shell and also on the fruit peel. Here, I just mentioned 2 examples on a cocoa bean cell contain a phytochemical compound which are potential for their use as a natural preservatives. And the secondly, the bioactive compound on the total content of tannin of the fruit peels of cacao from South Sulawesi. As also on a coffee, we also have an established system cultivation for cacao that has an optimal composition polyclonal cacao hybrid breeding stock in the field. Here we have the polyclonal parents composition that contain 2 clone parents. The second is a polyclonal parents composition that contain 3 to 4 clone parents. So this is also as the breed lines diversity work for cacao production. Okay, next. Yeah, here for the metabolomic study. So metabolomic studies also could address to prevent food loss. Metabolomic platform technologies are being employed to study the impact of the agricultural practices, processing and storage on the global chemical composition of food, also to identify the novel bioactive compound for authentical and also the region of classification. So various of Indonesian coffee is available from Sabang to Merauke Island with a distinct flavor and aromas. There are still a lot of some indigenous, also the local coffee varieties have not yet identified for their potential. So by using the multiple metabolomics approach, it can be determined which a metabolic class determinant may be affected by varied breeding activities developed by local breeder. The determination of the coffee metabolome will help future attempt to produce coffee seed with desirable characteristic and also best flavor profiles. Okay, next. As the same on the coffee, this is about the metabolomic study on a cacao. So on cacao, I also put targeted for reduced for food loss. The objective that could be addressed are to develop the biomarker that would be used to identify the nutritional and phytochemical compounds of Indonesia cacao jemblasa. And also we can to track the pleasing chocolate aroma, of course, here in a fermented beans, and also to obtain the resistance to insect and also disease association. So the expected outcome here that to find auto row of cocoa accession that have a good quality bean contribute to the composition, flavor, and quality of fermented dry cocoa beans. Next. Okay, I think this is the last, my last slide. So as the conclusion, current activities related to GAP, GHP, and also GD need to be optimized, deeply focused, and also sharpened for the genetic material use, as well as on the technological approach. And the second, the research collaboration, I think it's crucial in order to improve knowledge, translate research into the practice in order to reduce food loss. Okay, I think that's all. Thanks very much for the attention.
Yeah, thank you so much, Dr. Dwinita. Finally, I can open my masker. Yeah, ladies and gentlemen, after seeing the Dr. Dwinita presentation related to the on-farm strategies to reduce the food loss from cocoa and coffee commodity. Now we are going to the question and answer sessions for discussions. So firstly, I pleased to invite all of our speakers to come back to the floor. Professor Miura Sensei, Dr. Sastia, hopefully already come back to this floor. And then please to the all audience to just raise your hand up to directly give your question, and I give opportunity to go to audience to raise your hand. I'm sorry, I need to see my monitor. Nobody raise their hand right now, so maybe I will turn to the chatting room. Actually, there is one question from Nurfianto to Dr. Sastia Putri. Yeah, Dr. Sastia, I think your favorite today. To Dr. Sastia Putri, is there any portable quality authentication marker tool that can use for farmer?
Actually, that is our dream to use our information from metabolomics. Once we can get the marker from metabolomics study, we would like to work together with engineers to use this marker metabolite and make a portable sensor. But of course, it cannot be done by ourselves because our expertise is just until to find the marker. Then we need to feed this information to the engineers like nanotechnology scientists or physicists, or then we hope to make this kind of easy to use portable marker in the future. Hopefully Miura Sensei can help us.
Yeah, please, Miura Sensei.
Because yeah, we have to work together. It's a completely different expertise, but that is the idea, the target outcome.
Okay, thank you, Dasasya. Perhaps Miura Sensei may give insight to add.
Yeah, I think that the portable sensor can only detect say one kind of component, gas component, something like that. So I think the Sastia Sensei and Fukusaki Sensei can identify some specific gas component. Then we can make some specific, very small portable sensor device to detect such a special gas concentration with a very small sensor. So it's our target of the long-term target for the next step.
Okay. Yes, hopefully the dream will come, and we will collaborate each other to to make those kind of things. I will come back to Mr. Nurfianto. Maybe he will have a comment from the answer from Dr. Sastia as well as Miura Sensei. Dr. Nurfianto?
Actually, now the chat is also disabled, so maybe
okay.
Now if the audience want to ask questions, maybe only raise hand feature.
Okay.
No, we cannot use the chat feature now. Yes.
Okay. I see. Actually, there's several questions as well come to my chat, my private chat, and I will read to Dr. Sastia as well as to all audience. Dr. Sastia, actually we still have several questions from our previous session. In the first session, it has to be answered. Maybe this is the good opportunity to give a feedback of those questions. May I go through, Dr. Sastia? Yeah, it's still related to the fruit. From Nurul Hidayatun, is there any possible contradiction between the approach to reducing consumption loss to reducing consumption loss with food safety issues and standards as in Codex Alimentarius? Do you get the questions?
Yeah, I think contradiction between like keeping the standards of food and throwing away food. Yeah, so I think there should be no contradiction because the minimum requirement for us to produce food is to ensure that they are safe to consume, right? So that means the minimum requirement is food safety has to be obtained. So in order for us to make products that is safe to consume, that means it's very important to have a very good production process. So if the producer keeps the production process in line with the good practice for handling and production, then we can meet the standard. Then hopefully we can reduce the problem of food loss. But if, for example, when it reaches the destination country and then found that there is a contaminant, allergens, contaminant, pesticides, then the food is not consumed, then it has to be exterminated, right? So that means to ensure the product quality is good before being sold is very, very important to minimize the problem of food loss. And I just would like to say how impressed I am with the presentation from BRIN, and so many research ideas came to mind after hearing the presentation. So I'm very interested to work together in terms of like many different kind of effective ways on food technology, as well as what has already been mentioned, to investigate the cacao disease using metabolomics is also one of our interests. So hopefully we can collaborate in that topic.
Yes, exactly. We will make the like clustering and make the task force for another very deep discussion related to our collaboration, I think. Thank you, Dr. Sastia. Actually, please, the audience, if there is any questions for our 4 presenters. Okay, if there is no question anymore, maybe this time
Maybe
to...
for
Oh, yeah.
Professor Miura, can I?
Yeah. From Dr. Satrio, may I ask a question to Professor Miura? Please.
Yeah, it's very interesting presentation, Prof. Miura Sensei. Particularly, I see that you use electrical sensor. Is it right? Yeah. In one of my slides, we also develop chemical sensor. You can see one of my slides talking about anthocyanin. Yeah, anthocyanin, we proceed anthocyanin using freeze dry. It's for almost similar function with your research to detect shelf life of or quality of product or degradation of product after period of time. What is your opinion or your perspective about to collaborate between chemical sensor and electrical sensor?
So the chemical sensor, I think I'm not sure what kind of chemical sensor you are using now, but the sensing core should be sometimes related to anyway integrated in the circuits, like based on the silicon. I think if the specific component only say anthocyanin, I don't know, the one specific component is only the measurement target. I think we can make the very small sensors. So important thing is that we need to find out some material which will be which can be strongly respond to the target materials, and if it can be if we can find that kind of material, then we can put that kind of material onto the integrated circuit, and we can somehow measure the electrical characteristic change in the integrated circuit. So I think that we can measure the electrical energy very effective way. So what we can collaborate is that can you find out some physical mechanism to convert the chemical stuff into electrical energy?
Oh, okay.
Then we can make collaboration. If you can find some we can find some good material which can convert the chemical energy into the electric energy, then we can make very effective circuit to measuring the electric change based on the chemical concentration change.
Yeah. It's based on a natural dye.
So I think the key point is to make the specialized circuit. So we need to find out the special material which can respond to the target materials what you want to measure.
Yeah, thank you. I'm sorry to distract. I see here there are to our audience. I think this is special our guest, Fukusaki Sensei, and we see here Horticultural. So first, I give maybe the opportunity to Fukusaki Sensei first because maybe he has a comment or please, Sensei.
Okay, sir. Thank you. So in addition, the Miura Sensei's comment. So in consideration of the Miura Sensei and the Hirose Sensei's specialty, it's necessary to make the sensing system. So maybe particularly in case of sensing the anthocyanin, particular biosensor or chemical sensor that work in the aqueous space would be necessary. So once such kind of sensor installed, the electric signal can be operated by the Miura Sensei's technology. So the combination, the collaboration between the Miura Sensei's technology and your technology and the sensing device technology would be fine. It's my opinion.
Yeah, thank you so much, Fukusaki Sensei. And we come to the Dr. Horticultural. You raise your hand, please, if you have a comment or a question.
Yeah, can you hear my voice?
Yes, very clear, please.
Thank you. I have a question for Dr. Sastia. Let me introduce myself. My name is Noriyuki from Research Center for Agro-Industry. I would like to know how you determine the coffee composition based on roasting profile temperature. Is it any certain variable or method or roasting machine that you use to get the result? Because for now, we also have research related to coffee production, especially to develop smart coffee roaster, and hopefully maybe for the future we can collaborate. Maybe this is my question. Thank you.
Thank you very much. So based on our analysis, roasting process gives a very significant effect to the change in the metabolome profile. Then the roasting effect is more significant and more, it's more crucial to change the total metabolome profile after roasting, from green bean to roasting. So even you have many different kinds of green beans coming from many different area or different species. Once it is subjected to roasting, then the total metabolite profile change, right? So that means because it's so influential, then we need to control the roasting process to be completely same. So in our case, the coffee, either we analyze the coffee in green state or we only use the same coffee roasting machine always in the same temperature and controlled and roasted by the same person. So because our technology is so sensitive that even the differences of roasting will affect the result. So that means if we would like to see other factors other than roasting, then we need to make sure that the roasting condition is controlled to be very, very homogeneous, same. Then to answer your question, also to make the smart roasting, as I mentioned, we can detect differences in roasting because it's very sensitive. So if you employ different types of roasting method, then we could also see the change in the metabolite profile. For example, not only in coffee, but in cacao, we investigate the effect of roasting in different temperature and the length, duration of roasting. and how it affects the cacao beans metabolite profile and how it will later affect the quality of the final product of the chocolate. So we do this kind of experiment to investigate the effect of roasting to the metabolite composition. And most importantly, after roasting, there's a generation of many volatile compounds. We are also able to detect these volatiles that is generated after roasting. Thank you, Pak. So I'm very looking forward to collaborating with you regarding your project as well.
Yes, thank you, Dr. Sastia. Is there any comment from Dr. Haryoki, or is enough? And
Sorry, I'm not doctor yet.
oh no, no problem.
Okay,
No.
but it's okay. It's
Probably
okay.
something
Maybe,
yeah,
maybe
no problem.
next I will. For Dr. Sastia, it's mean that in roasting process, you give the process to a professional roaster, because every single species for the coffee have a different composition. So maybe if we not a professional roaster, I think it's very difficult to approach the process.
Our collaborator is in Puslit Koka in ICCRI, and they have this roasting machine in the facility that is used for cupping test. So it's already long time use, and from 2013 until now, it's always roasted by the same roaster and same roasting machine professionally. Yeah, so to ensure. So every time we want to do analysis, we send the coffee beans to Puslit Koka, and then they will return back the coffee beans already roasted. And we don't change the roasting because, as I mentioned, it will affect. So within the same batch of analysis, all of the coffee beans have to be consistently roasted.
Oh, okay, I get the point.
Yeah, thank you so much, Dr. Haryoki and Dr. Sastia, for your very nice explanation. Yeah, I think this is a very nice and very warm discussion, very fruitful, but however, we are limited with time. So yeah, unfortunately, I need to end the sessions. And ladies and gentlemen, we finally come to the end of our sharing session today. And before I close this sharing session, I would like to take the conclusions from what the speaker has presented, as well as from discussions. So first point is secure food supply chain is required to prevent food loss through the smart monitoring system. So we need to become accurately as a fundamental for food quality. And the second one, unique characteristics of the product is important for selling point. However, it should be scientifically proven by the deep research and as well as very strong collaboration. The third point is extend the shelf life product is the important issue in Indonesia, especially for traditional product. And then several areas can be the topic for our collaboration, including marine product, halal product, as well as stunting prevention product. And the last conclusion is reducing food loss from on-farm can be through several strategies, from good agricultural practices, from good handling practices, as well as good distribution. And yeah, those are our conclusion today. Hopefully after this, we will still continue our communication and to the reality, to the research project that we are going on together. Thank you again for the presenters today, Miura Sensei, Dr. Sastia, Dr. Dwinita, Dr. Satrio, as well as Fukusaki Sensei, always together with us until right now. And thank you for everyone for attending today's sharing session. And finally, give the applause to the speaker for you all. Yeah, thank you so much. So on behalf of Research Organization for Agriculture and Food, BRIN Indonesia, thank you for joining us today and have a great rest of your day. And I also send the regard from our chair lady, because she has another presentation in other program. Thank you so much. I will give the floor back to Miss Wardah. Please, Miss Wardah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for our moderator, Mr. Andi Febrisianto, PhD. Ladies and gentlemen, for the next session, we would like to give certificate as appreciation and gratitude from Chairman of Research Organization for Agriculture and Food BRIN to all speakers and all moderators today. For the first, Professor Noriyuki Miura, and next for Dr. Sastia Pramaputri, and next for Dr. Dwinita Wikan Utami, then to Mr. Satrio Kridowahono, PhD, and also to our moderator today, Mr. Andi Febrisianto, PhD. Thank you. Ladies and gentlemen, we have now come to the end of our event today. Thank you for Mrs. Puji Lestari, PhD, Professor Noriyuki Miura, Dr. Sastia Pramaputri, Dr. Dwinita Wikan Utami, Mr. Satrio Kridowahono, PhD, Mr. Andi Febrisianto, PhD, and all participants. See you soon at the next sharing session. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you.
Thank
Arigato.
you. Terima kasih banyak. Ya, thank you very much.
See you next.
Muna muna keke